Hi students, today I am here with a couple of multiple choice questions as well as question from NCERT which will strengthen your understanding of ray optics. Some of these are very basic, some are from the 2019 JEE mains paper and some are from past NEET examination papers. Okay, let us start with the first one. It's a NCERT question. It's about a myopic person. A myopic person's far point is 80 centimeter. What is the power of the lens required to see very distant objects clearly? Directly we have answer. The focal length of the lens for correction of myopia, we have a shortcut equation. The focal length is given by minus far point. The focal length is equal to minus far point. So, the focal length is nothing but minus 80 centimeter. This is equal to minus 0.8 meter, and we want power of the lens. Power is given by 1 by f, and that is given by 1 by minus 0.8, and this gives you minus 1.25 diopter. Minus indicates it's a concave lens. You studied that correction of myopia is by using a concave lens. Next question is about hypermetropia. The near point of a hypermetropic person is 75 centimeter from the eye. So, the normal near point is 25 centimeter, but this man has got it from, it's at 75 centimeter. What is the power of the lens required to enable the person to read clearly a book held at 25 centimeter? So, you can see that the object of interest is the book and it is held at 25 centimeter. So, this can be done in three different methods. The first method, you can go for the conventional method. You can take u is equal to object distance is minus 25 centimeter, and the lens will form an image of this object at his far point 75. So, the image distance will become minus 75 centimeter. We do not know focal length, that we have to calculate. Okay. Now, tell you about the sign convention. This is the eye of the person. Normal distance is 25, but this man's far point is 75. Light comes in this direction, positive direction. You measure everything from this side, so this becomes negative, this also negative. That is why I got u negative, v negative. F must be calculated. Go for the equation 1 by f equal to 1 by v minus 1 by u. Substitute 1 by v is minus 75 minus 1 by minus 25. This gives you 1 by 25 minus 1 by 75. So, we will get 1 by f equal to 1 by 25 minus 1 by 75 is 75 minus 25 by 25 into 75. We can see this is 50 divided by 25 into 75. This is 1 by f. So, f is equal to, you can see 25, 50 goes 2. So, this gives you 75 divided by 2, which is 37.5 centimeter. See, it is coming with a positive sign. It indicates that it's a convex lens. You also studied hypermetropia is corrected by placing a convex lens. This is first method. Let us go for the next method. Next method, you by heart an equation. Hypermetropic correction, 1 by f is given by 1 by np minus 1 by d. This is but with the Cartesian convention. With the Cartesian sign convention. With Cartesian convention you can use this. And what is the near point of the person? Near point of the person is minus 75 minus what is the value of d? That is minus 25. You reach the same value, 1 by 25 minus 1 by 75 is 1 by f. Just like the previous case, you calculate this to be 37.5 centimeter. That is method 2. Now, method 3. Method 3 is direct equation 1 by f equal to 1 by d minus 1 by near point. 1 by d. No sign convention. You don't need to use no sign convention here. So, if you are not happy with sign convention, whenever hypermetropic problem comes, directly use this equation. Do not apply any sign convention. D is 25 minus, what is the near point of the person? 75. This gives you 1 by f equal to, this directly gives you previous calculation, this gives you f equal to 37.5 centimeter. For entrance examination, I suggest this method, no convention, direct values only. This is a super duper question from the NCERT textbook. If you see previous NEET paper, previous JEE paper, you can see various version of this one. More than that, this has come in the CBSE board examination at least 3 times directly, but with slight variations. Fine. Now the question is that there is an object here and there are 3 lenses which are not in contact. They are not in contact. There is separation between lenses. First one is a convex lens, focal length 10. Second one, plano concave, focal length minus 10. Third one, again a convex lens, focal length 30 centimeter. Question, where is the final image formed? Where is the final image formed of the system? What happens? Light will come from the object, it will undergo refraction in the first lens, then refraction in the second lens, then refraction in the third lens, and you get an image. Now, the image of the first lens will be the object for the second lens. The image of the second lens will be the object for the third lens. So we have to deal each lens separately. So when you deal the first lens, the measurement will be taken from this point. For the second lens, measurement must be from this point. For the third one, measurement must be from this point. So you have 3 optical centers to be dealt. First one O1, second O2, third O3. So for each lens, you have to apply sign convention, but don't worry, light comes only from the object in this direction, so that is the positive sign for all the 3 lenses. Okay, let us work out. For the first lens, focal length is 10 centimeter, object is here, light goes in this direction, that is positive direction, so measurement must be from here. This is what we call as optical center 1, O1. Measurement is towards the left side, so u equal to minus 30. Let us calculate the image distance using the shortcut equation uf divided by u plus f. This gives you u minus 30 into f plus 10 divided by minus 30 plus 10. This gives you minus 300 divided by minus 20. Minus minus cancel. This gives you V is equal to 15 centimeter with the positive sign. That means the image of this object will be formed by the first lens at 15 centimeter to the right. So from this lens 15 centimeter. So the first image must be formed here. That's interesting. That's exactly at the location of the third lens. Let us consider the first lens and the object. So object is here at 30 centimeter, first lens is convex, focal length is 10 given. So focal length is plus 10 centimeter, object distance is from the center of the first lens to the left side, and light will come in this direction. So this is positive sign, this is negative side. So object distance is minus 30 centimeter. From lens equation directly we get equation V equal to uf by u plus f for a lens, and this is given by minus 30 times 10 divided by minus 30 plus 10, which gives you minus 300 divided by minus 20. This is the value V. So V is equal to minus minus cancel, 300 by 20 equal to 15 centimeter. Positive 15 means what? From the optical center to the right side. So where is 15 centimeter from the first lens? From here. It's given in the question that the second lens is at 5, third lens is at 10. So the image of the first lens will be here. This is the image I1 at 15 centimeter to the right, which is going to act like the object for the second lens. For the second plano concave lens, the first image will act like object, and we know this is called as a virtual object, and that object is on to the right side. Light was coming from the left side to the right side, so this is positive. Focal length of the lens is given as minus 10. What about object distance? Object distance should be measured from this center to the right side, and that is you can see the distance from the first lens to this point was 15, and the distance between that image and the concave, plano concave lens is only 10 centimeter, but that is positive 10 centimeter. Now apply the equation V equal to uf by u plus f, substitute values. U is plus 10 into f is minus 10 divided by u is plus 10, f is minus 10. this gives you, see, this is divided by 0. Divided by 0 is not determined, not doable, but we will approximate. In physics we will always approximate something divided by, this is minus 100 divided by 0, so we will approximate this as infinity. So for the second lens, the plano-concave lens, image will form at infinite distance from the lens, infinite distance from the lens. Okay. For the third lens, it is a convex lens, focal length is plus 30, but where is its object? Its object is the image formed by the plano-concave lens, and the image formed by the plano-concave lens is at infinity. So we can say u is infinity for the third lens. So for the third lens, which is a convex lens of focal length plus 30 centimeter, the object is the image formed by the plano-concave lens, which is at infinity. So we can say u equal to infinity. Now when u is equal to infinity, you can't apply this equation, you can't use this equation uf by u plus f, because this will come in the infinity by infinity form. So we can't do this, we will go for the other equation, 1 by f equal to 1 by v minus 1 by u. We will substitute for focal length, what that is equal to 30 plus 30 equal to what is v, we don't know, minus what is u, u equal to infinity. And you can see 1 by infinity tends to become 0, so we will get v is equal to plus 30 centimeter. So the final, the image of the convex lens here will be at 30 centimeter to the right side. So this is the lens from the center 30 centimeter. This is the final position. So I will write 30 centimeter. So this is where we are going to get the image. So the final image position is 30 centimeter to the right of the last lens. To understand what was happening in the previous question, I will take one point on the object, only one point on the object, and I will consider one light ray going straight, one light ray going like this one, and that will go through the optic center without any deviation, will go through the next optic center and through the next optic center and will go straight. That light ray will not undergo any refraction. Take another light ray and one here in this direction. These light rays would want to converge to this point. If these second lens were absent, this would have definitely converged here. That is what we calculated as the first image at 30 centimeter. But what happened? In between it is intercepted by a plano-concave lens, so this light ray cannot reach the point 30 centimeter. So what will happen? From here, this will get deviated, this will get deviated, and this is going to infinite distance. Infinite distance means it will become parallel, it will become parallel to the principal axis, and you can see parallel light rays incident on a convex lens like this will definitely focus to its principal focus. In the board examination, once they ask it, what must be the distance between these two lenses to get the image here, image at the focal point. You can see that this being parallel, whether you move this convex lens away or closer, this will not affect this focal length. Okay. This is a question about a telescope. Since it is using lenses, it is a refracting type astronomical telescope, and nothing is mentioned about the final image. So we will take the normal mode where the final image is at infinity. If the final image is at infinity, you studied that the objective and the eyepiece, the final image at infinity means, the first image must be at the focal point of the eye lens. So this distance must be f eye lens, and the objects are at infinite distance, so the first image will be formed here. So this distance is what we call as f of o. So the distance between the two lenses in the normal mode, is fo plus fe, that is asked here, fo plus fe. Now we studied the magnification, the magnifying power, the angular magnification of a astronomical refracting telescope is the ratio of fo by fe. I said do not apply any sign convention here, simply take the magnitude of fo and fe. What is the magnitude of the focal length of the objective? It is given 144 divided by focal length of the eyepiece is given as 6 centimeter. Be careful about the unit, both are in centimeters, so there is no problem now. This gives you 24. Okay, that means this telescope can magnify things 24 times. Objects will appear closer by 24 times. And what is the length of the, what is the separation between the objective and the eyepiece that's there? That is FO plus FE, which is 144 plus 6 equal to 150 centimeter. 150 centimeter is a 1.5 meter. It's quite long. You must have seen telescopes. Those astronomical, they are long because of the large focal length of the objective lens. This is again about an astronomical telescope. Giant refracting telescope has an objective lens of focal length 15 meter. Oh my god, 15 meter objective focal length 15 meter. The previous one was the total length of the telescope was only 1.5 meter, but this the objective itself has got 15 meter long. Okay, eyepiece 1 centimeter. See, eyepiece very small. Why? Because the angular magnification is given by the equation FO by FE. So if you want large magnification, you have to increase objective focal length and decrease eyepiece focal length. So if you are given two lenses, which one to be selected for objective, which one should be selected for eyepiece? For objective, long focal length, eyepiece short focal length. And objective also has got one more property, it should have large light gathering capacity. So the lens should have a large diameter, aperture must be high. Now let us calculate the magnification here. One is 15 meter, be careful, don't get cheated by the unit. 15 meter, other is 1 centimeter. 15 meter is nothing but 1500 centimeter divided by 1 centimeter. So this has got an amazing magnification of 1500 times, 1500x, 1500 times. That is the answer to the first part. Now the second part. Second part, if this telescope is used to view the moon, what is the diameter of the image of the moon? Be careful, diameter of the image of the moon formed by the objective lens, not by the telescope, formed by the objective lens. The diameter of the moon is given 3.48 into 10 raised to 6, and the radius of lunar orbit is also given. Oh my god, what is this? Where are we heading at? Okay, so let us do this. I think I need a diagram. I'll explain this using a diagram. So this is what is happening. This is the objective lens, and this is moon. Oh my god. My pen cheated me. My pen. This is moon, and this is the image of moon. Moon is at a large distance. So when the objects are at infinite distance, the image will be formed at the focal length. So this F is the focal length of the objective lens. Now the diameter of the moon. This is the diameter of the moon. Let us call it as diameter D. And let us call this approximately as the distance S to moon from earth. Okay. Now this creates an angle theta here. Since the distance is too large, this theta will be very small. So we can say angular size of the object is equal to arc length divided by radius. Theta of the objective is arc length. We studied that when the angle is very small, instead of arc length you can use the chord length, so that is d by s. Now see, the same angle appears here at the image. This is the diameter of the image. This is the diameter of the image. Let us call it as d, and the distance from the lens to the image is nothing but the focal length. So what is the angle created by the image, and that angle created by image is nothing but the diameter of the image divided by focal length, and these are equal. The angle created by the image and the angle created by the object here. The objective lens does not create any magnification, any angular magnification. What is asked? Okay, from the diagram we understand that theta O is equal to theta I. Fine. So substitute theta O d divided by s is equal to small d divided by f. It's asked what is the diameter of the image, and that's nothing but f into d divided by s. Substitute the values, calculate. This is an application type question where you have to bring in other concepts too. this is bit complicated. A particle revolves in clockwise direction as seen from point A. You can see this is a convex mirror. There is a line AB and there is a diagram shown. This is a particle rotating in the clockwise direction, and the one revolution in 2 seconds, that means the time period is 2 seconds, and the radius is 1 centimeter. So radius of circular motion is 1 centimeter and the time period is 2 seconds. So we can say this is the radius, this is 1 centimeter. Okay. The radius of curvature of the mirror, is given as 20. Naturally focal length must be equal to 10 centimeter, and this is moving at a distance of 10 centimeter. This is the crystal. Okay. And AB, the axis of the circular motion, is the principal axis. So it's moving around the principal axis. Okay. Now what are the things that we have? We have focal length equal to 10 centimeter. Convex mirror, focal length is positive as per sign convention. And what is object distance? Object is in a plane here, right? So that plane from the principal axis to the center, that distance is 10 centimeter. So U is equal to 10 centimeter. Light from the object falls in this direction, positive direction. From the pole you measure in the opposite direction, so that is minus 10 centimeter. Right. Now what is the equation for image distance in a mirror? Shortcut equation. What was that equation? That is given by UF by U minus F. Substitute. U is minus 10, F is 10 divided by U is again minus 10, gives you minus 100 divided by this is minus 20. So this will give you plus 5. Obviously, a convex mirror will produce images only behind it, which are virtual and erect. So that is plus 5, means from the mirror 5 distance backward. So this somewhere here 5 centimeter. And we know that the image produced is always erect. Erect in the sense, suppose the object is kept vertical upward like this one, the image is also like that, but it is smaller in size. How small? For that we need to find magnification. Magnification of a mirror is given by minus V by U, and we have minus, what is V? V is plus 5 divided by what is U? U is minus 10. This gives you plus 1 by 2. Plus indicates is an erect image, and 1 by 2 indicates it's half the size of the object. So if the object has got 1 centimeter height, the image will have only half a centimeter height, half the size. So we have magnification. Now what is asked? The image of the particle and its speed, the direction of revolution of the image of the particle and its speed. What is the speed of that one? Let us discuss speed. This is a convex mirror, I mean image of a convex mirror. Okay. Now when you look into the mirror, to understand this, go and stand in front of your mirror, in the plane mirror, and in the plane mirror you move your hand. For you are the observer, you move your hand clockwise, and you can see the image also moves in the clockwise sense, rotation. Similarly, if this is the pole of the convex mirror, and if I stand here, I see erect images. So these are the images of something in front of the erect image. That means if I raise my hand upward, the image will also raise hand upward. If I direct downward, the image will also do that one here like this. If I show my hand to the right side, this will also show it to the right side. So the sense is always the same in a convex mirror. In concave mirror it is not. So if the, okay, now as per the diagram, I am bringing the diagram here. This is the convex mirror. This is AB line, and the particle was moving right. You are observing from A. So observer, the particle, then the mirror. Observer, particle, mirror. So observer here, the particle is going clockwise like this. So when the particle is going clockwise, I think in this board itself we can see that rotation. If the particle is going clockwise, the image will also go clockwise. So the sense of rotation of the image is same, clockwise. But what about the size? You can see that the particle was going in a circle around the principal axis with a radius of 1 centimeter, but behind the mirror the image was going in a circle about the principal axis where the radius is only half centimeter. Fine. So, the radius of the circular path has changed. What about time period? The time taken for the revolution by the object and the image will be the same, because you can see if I move my hand once like this, the image will also move the hand once. So, the time period is same. So, what was the time period? The time period was given as 2 seconds. So, what is angular velocity omega? Omega is given by 2 pi by t, which is 2 pi divided by 2, which is equal to pi radian per second. It is asked what is the speed of the particle. In circular motion, we know speed is given by r omega. What was the speed of the object? Object was moving in the circular path, radius 1 centimeter. So, the radius was 1 centimeter. So, we can say this radius was 1 centimeter, which is 0.01 centimeter into omega was pi. This was the speed of the object. Well, what is the speed of the image? Speed of the image is equal to, the radius is now 0.005, half of that one, into pi. Sorry, there is no decimal point here, into pi, because pi is the angular speed. So, this is the speed of the image, this is the speed of the object. Okay. That is a very good application of circular motion and ray optics. You can expect similar questions for JEE examinations.